This is the second in a series of short videos on the Hoekstra Performance Curve model for gasoline desulfurization. The key to optimizing a gasoline desulfurizer is to maximize desulfurization and minimize octane loss. That's why we focus on a single curve of octane versus product sulfur, and we call it the performance curve. This is the performance curve for a feed that we have analyzed. And in the first video, I showed how with this spreadsheet, we can see the effect of adding a splitter to the process to remove C5 light naphtha. And we can also see the effect of a selectivity improvement. This purple curve for a 40% more selective process without a splitter, and the dashed purple curve for an improved selectivity process with a splitter. This is the full interface sheet for this performance curve model, and just below the chart are checkboxes that control which output cases are displayed on the chart. So as I check these boxes, the curve for that case is not displayed. Just to the right of the checkboxes are the calculated octane losses for that case for 3 product sulfur levels, 10, 30, and 50 ppm. So all these octane losses are calculated for a set of input data for all 4 cases, and the checkboxes just control which output is displayed. So the right half of this interface sheet is all output data. This light gray section of the interface sheet is called controls, and it allows you to adjust 3 factors. The splitter is the percent of C5s split out of the HDS feed. So it's set for 100% of the C5s. If you reduce it to 0, then the dashed curves will correspond with the solid curves because there's no splitter. The selectivity will affect the purple curves. If the selectivity is higher, the purple curves for an improved process will go up, and if it's set lower, the curves will go down. And the heavy tail is the percent of the measured heavies in the feed. It's set at 100% of what we measured in the feed, and if you take it down to 0, that will indicate the effect of removing those heavies from the feed, and you can increase it as well to see the effect of increasing the amount of heavies in the feed. And finally, this inputs section defines the feed. There are 10 numbers that define the feed. And what I'm going to do is I'm just going to scroll through 20 different feeds that we have analyzed that are actual feeds for gasoline desulfurizers. And you will see that as I change these, the numbers in that input section change, and also the curves change. This is the biggest factor in calculating the performance curve, is the composition of the feed. And you see that as I move through these different feeds, the performance curves move all over the map. So a key thing to understand your performance curve is to analyze your feed and break it down into these lumps that this model can then use to calculate the performance curve. This spreadsheet has been developed as a tool for making decisions and has been used for the following applications: capital investment decisions, licensors, process design, feeds, cut points, catalysts, and Tier 3 strategy. If you have a gasoline desulfurizer, your engineers and planners should certainly have this tool. With an analysis of your feed and this spreadsheet, you'll be able to see exactly what is happening in your unit, make accurate performance and cost estimates, and make better decisions for Tier 3 gasoline. We have also developed two other spreadsheet models. I have not shown them here. One is a desulfurization kinetic model, and the other is a octane market model, which calculates the impact of deep desulfurization on the U.S. octane supply. These three spreadsheet models have given our clients ready access to the best available information for making decisions about gasoline production in the Tier 3 world. Thanks a lot for your attention. Our spreadsheet models use the results of a 3-year multi-client research project and have been validated in field testing on many commercial units. The reports on our 3-year project, which include these spreadsheets, are available immediately to anyone at negligible cost. Please contact me anytime for an offer letter.